the two things you want to consider are, one, are these like terms? And two, do I need to distribute anything first? Okay. So the two things you always want to consider are, one, are these like terms? And two, do I need to distribute anything? So one, how you know if these are like terms are, you have to consider two things. One, if they have variables. And if they have variables, the second thing you want to consider is the exponents the same? Okay. So you can only combine variables that have the same exponents. So if we look at these different things, one, we cannot combine 5p squared minus 3. You can think about this as saying 5 2D objects minus 3, and this is saying 2 2D objects, and this is saying 3 3D objects, right? So we cannot combine these two things because one of them is p squared and the other one is p to the third power. Okay. The second thing we want to consider is, do I need to distribute anything? Well, if you look here, there's a plus sign in front, so you just have to distribute the plus. It doesn't change any of the signs, so it's fine. So what I like to do is I like to reorder this in terms of highest exponential value. So you can see here that p to the third power is the highest value. So the first term I'm going to write is 3p to the third power. And then I'm going to go ahead and try to combine these two together because they have the same p value. So then it'd be plus 5p squared plus 2p squared, and then there's just the minus 3. These two I can combine to, because they're like terms. How many of that total object do I have? Well, I have 5 plus 2. So I would just get a total of 7p squared minus 3, and that would be my answer. So if this reminds you of the chapter we just did, it should. It's very familiar, or should be familiar. You're really just adding like terms. Question?
Does the order of the answer matter? Like, should I put 7p squared minus 3p minus 3?
I will say yes. Typically, you do want to put it in order of exponential value because when you graph it, it makes a big difference in how you look at the graph. So ordering it is, yeah, it's more important for how you know what graph you're dealing with. Okay, secondly, we're given this problem right here. Something to note also is that when you're combining like terms, you want to make sure that the variables are the same. So one of the things you also want to consider are the variables the same? If they're not the same letter, you cannot combine them. So if they're not the same letter, you cannot combine them. So as an example, if this is an A and this is a B, even though if they had the same exponential value, you would not be able to combine those two terms. Okay. In addition, if they had multiple letters, you can only combine, again, if they're exactly matching with the variables. Okay. Okay, so here, first thing I want to consider is what are the like terms. You can see here there's a to the third power, and then there's negative 4a to the third power. So those would be like terms. The second like terms would be negative 2a squared and the 3a squared. You can see here there's a negative in front of the parentheses. So what I can do is I can actually distribute that negative first. So let me go ahead and rewrite this to show you that I'm going to redistribute the negative. So the 3a squared becomes negative 3a squared. The negative also distributes to the second term. This becomes positive 4a to the third. You can see here that I'm going to reorder it in terms of like terms. This would be 4a to the third power plus a to the third power minus 2a squared minus 3a squared. You can skip this step if you don't need it, but again, I'm just showing you what I'm doing. Then we have 5a to the third minus 5a to the second power. And if you look here, we cannot combine these terms here because a to the third power, remember that it's a to the third, while this one is a to the second. So when you combine like terms, you want to make sure, do they have the same variable? And then, are they to the same power? If they are not to the same power, you cannot combine those terms, okay? Just imagine you're talking about 3D objects here and you're talking about 2D objects here.